In this module, we're going to look at structural and physiological adaptations in endotherms and ectotherms. So you'll be learning about different endothermic and ectothermic adaptations. In particular, their structural and physiological adaptations for both cold and hot environments. Structural adaptations are physical features of an organism, such as their shape, their body, or any other structure in relation to the body that allows them to increase their chances of survival to better suit their environment. Structural adaptations that assist with temperature control include insulation, such as fur. Now, your cats, dogs, rabbits, or mice have fur, and the fur can either be thicker in winter and thinner in summer. And there's some organisms, such as I've owned a horse before, and it was in a cold environment. In winter, this horse grew extremely thick coat because of such the colder environment. When I brought that horse into a warmer environment, the thickness of their fur in winter changed. So in a warmer environment, it doesn't get as cold in winter, and they actually can change the fur length to suit the environment, which is amazing. Now, hair, we can apply that to us. There's males and females. In general, sometimes females tend to have longer hair, and this actually does produce more warmth in both summer and winter. And men that cannot grow hair, for example, or even some females that do go bald, might complain that they're a little bit cold in winter because their head does get cold, and that's because they don't have that layer of insulation there. Now, we've got feathers on birds, the insect scales and coats that enable a layer of air to be trapped to reduce the amount of heat lost. The feathers of the emu act as an insulation to reduce heat gain or loss. Blubber. Now, blubber is actually fat. Literally, it's fat. Blubber is another form of insulation to reduce heat loss from organisms living in water, such as the Australian fur seal. Now, it's actually literally a layer of thick fat. And it's not just in seals, it's also in whales and other organisms that live in the ocean to protect them from extreme cold temperatures. Penguins are another one. This significantly minimizes heat loss. Physiological adaptations focus on the inner body functions instead of the actual structure of the organism. Metabolic activity is important for the functioning and survival of individuals, but this activity also generates heat within the body. The rate of this activity can be altered to ensure a better chance of survival in warmer or cooler environmental conditions. Hibernation and torpor are examples where organisms lower their metabolic rate to conserve energy, and as a result, they reduce the amount of metabolic heat energy that they generate within their own bodies. So bears are a really good example. Hibernation is an extended period of inactivity in response to cold, where the body temperature does not actually drop below 30 degrees Celsius, but the heart rate and oxygen consumption drop considerably. So what this actually means is an endothermic animal, such as a bear, can actually go long times without eating food, and they actually do still maintain their warmth, but their other demands, metabolic functions, actually slow down, and this tends to be for an extended period of time. Hibernation is a state of greatly reduced body activity used to conserve food stored in the body. You'll actually notice that these organisms, before winter comes, they eat different foods to stock up on fat. So if they can, they might catch more fish to stock up on their fat before winter comes, so they can use their fat stores while they're in hibernation. Some animals hibernate for part or all of the winter. The animal's body temperature drops, its heartbeat and breathing will slow down, and it uses little energy. Examples of animals that hibernate are ants, snakes, black bears, beavers, and ground squirrels. And you can see that snakes and ants are ectotherms. So this actual behavior happens in both endotherms and ectotherms. So hibernation. So the term estivation is for animals that actually hibernate during hot. So there's hibernation, which is like sleeping in colder environments. Estivation is hibernation in the hotter environments. For example, the bogone moth migrates to spend the summer months in caves in the Australian Alps, and that's actually to keep cool during the summer period. Now, torpor is another form of hibernation, but it's not as long. So a state of torpor is a short-term hibernation. Their body temperature can go well under 30 degrees, and it actually mimics the outside environment. If you actually find an animal in torpor and see one outside environment, it actually will walk around in a sleepy state. And this sleepy state is because their metabolic processes have slowed right down. So an animal in torpor, it's similar to hibernation, but torpor tends to be for a shorter period of time. For example, the mountain pygmy possum. If the ambient temperature is high, endotherms have a physiological cooling mechanism as well. So the rate of heat loss from the body can be adjusted by altering the flow of blood near the body surface. So kangaroos tend to have large, thin ears, and they also have long paws. And what they actually do is their blood vessels dilate in this environment. When it dilates, the heat is released. This is called vasodilation. So this releases heat, especially in the ears, as it is a thin surface and heat can easily be lost. When cool, their vessels constrict again. So when it is colder environment, the vessels will actually shrink below and go more into the internal part of their paws and their arms and their ears, and they'll constrict back so that they're not releasing or not losing too much heat. Endotherms eat more food than ectotherms. This high food intake results in an increased level of metabolism, which is required to produce the heat to begin with. Compared to reptiles of the same weight, mammals use at least 5 times more energy than reptiles. So adaptations, there's 5 major adaptations, how animals respond to stimuli in their environment. Number 1, and this man here has it, he's sweating. So it's a physiological adaptation. Sweat evaporates from the surface of the skin and it can cool the animal. Number 2 is shedding. Now, like I said with the horse example before, the horse might get really, really thick fur in winter, and in summer, it needs to actually get rid of this excess fur. So, and this here over here is a picture of a Samoyed, which is a species of dog, and you can see here that it's a very, very fluffy dog. In winter, that's how much fur it sheds, and when it actually sheds, it comes out in clumps. It's not single hairs. We might lose hundreds of hairs a day. This here, there's millions of hairs built up there, and that comes out in clumps. So animals may form thick coats of fur or feathers to insulate their body from cold weather. When it is hot, the animals shed to provide a cooling effect. The third one is panting. So it's a physiological adaptation. Panting means to breathe heavily. This causes an increased airflow, and as a result, there is an increase in evaporation from the animal's mouth and lungs. Examples are dogs and lions for this one. Shivering is number 4. So it's another physiological adaptation, and it increases heat production. It is a natural response to a temperature drop outside the body. It increases the rate that energy is turned into heat. Humans shiver, and you'll actually find that some dogs and cats also shiver as well, and there's other animals that also do use that mechanism. Number 5 is changing positions. As animals, we're very lucky that we can actually move to a different location, which is a behavioral instinct. And by moving location, organisms can seek a cooler environment by finding shelter or shade. You'll find that cows actually do this, or horses do this in the middle of the day. Adaptations. So can you think of different behavioral, structural, or physiological adaptations that endotherms or ectotherms have to make them more suited for their environment? Now you can draw up a table. We've got behavioral, structural, and physiological. Press pause here to fill out some examples from this table. You can use the video examples, or you can make up some of your own examples that you have and you come up with in your own mind. Okay, let's look at some behavioral. So we've got hibernations for cold. There's estivations for hot. So these are behavioral adaptations, although the hibernation and estivation are also a physiological. So sometimes it can actually be linked and can be more than one. Migration, which is seasonal, and that's behavioral. Shelter, for example, they might burrow or seek shade or go to a tree or even find a cave. Now some structural adaptations. There's insulation, so we've got fur, fat and feathers. Now fat, you can also call it blubber, is a better term. There's lighter colouring for hot weather and there's darker colouring for cold weather. In one particular lizard, it actually can go darker when it's colder to absorb more light and lighter when it's hotter. Physiological. So we've got control of blood flow. So for example, vasoconstriction, which is where your blood vessels constrict to conserve heat, or vasodilation, which is where your blood vessels actually dilate and can release heat from the surface of your skin. There's countercurrent blood flow to increase surface area. So this is where your blood vessels come to the surface of your skin when it's really hot, and they separate from each other to try and give each other more air to cool off. Or it can vasoconstrict, and when it actually goes, they actually sort of clumps together. So the blood vessels clump together in the middle of your arm, for example, in order to maintain the heat in the center part of you to save heat. Now we've got some more behavioral adaptations. Nocturnal, for example, a bat. You can vary surface area to volume ratio, for example, leaves. And leaves might, in the middle of the day, might droop. And by that, we're decreasing the surface area to volume ratio. Structural. So we've got evaporation, can be a structural adaptation, and varies in surface area to volume ratio. So we've got pine needles, for example, which might be, they're really small and thin, and it might be to suit that environment. And you find in warmer environments, the leaves are actually quite large. So they vary the surface area to volume ratio to suit their environment they live in. Physiological. So there's evaporation, for example, sweat, or metabolic activity. So for example, we eat less to slow down metabolism and conserve heat, like bears. Animal examples of adaptations. So complete the table on the next page. You draw 4 columns by 9 rows. So this is the table that you'll be drawing up. Here's 4 columns here, and this is the rows here. So for these rows, these are examples of adaptations. So animal curls in a ball, limbs are drawn in. There's large thin ears, burrowing and basking in the sun. They're different types of adaptations. And on the top here of the table, we have a type of response or adaptation, and we have an example of an animal which it occurs, and then an explanation. So here we go. We've got, for animal curls up in a ball and draws in it, its limbs are drawn in. Now you can use different examples for this, but I've got an example, and it's a behavioral response. The animal that it occurs in is an echidna. And the explanation, and it protects itself from predators. So you'll find that if you walk near an echidna, it'll actually draw its limbs in and curl up in a ball. Now, if you chose a cat, for example, for this, it may have a different reason. And the reason, it's still behavioral for a cat, but it might actually be to conserve energy and to conserve the warmth. So you can choose different examples here, but I'll give my own. So press pause here and have a go yourself. Okay, so large thin ears, you can see that is a structural or physiological adaptation. It's both here. An example that I have used here is a kangaroo. They do have the large thin ears, and the explanation is so that it can release heat in summer. Burrowing, it's a behavioral adaptation. An example is a desert mouse that does it, and why? It's to lose heat or to protect itself from the heat during the day. They might bask in the sun. So that's a behavioral adaptation, and it could be a desert lizard that might do that. And the explanation is it would gain heat. Now we've got some more examples here. So shivering, panting, red face, and thick fur. So for shivering, it's a physiological adaptation. The example, humans, we shiver. And the explanation is that we gain heat via the contraction of our muscles. So our muscles contract and we make heat in our body. Panting, an example, it's physiological. It can happen in dogs and lions, and the reason why is to release heat via evaporation from the mouth. Red face, now that one's physiological. It happens in humans, and the reason why is that we lose heat via capillaries. So if you're the type of person that does exercise and turns really red in the face, the reason why is because our capillaries actually rise to the surface and release that heat. Thick fur, it's a structural adaptation. It occurs in dogs, and it maintains heat in cold climates. Now, in summary, endothermic and ectothermic organisms have different types of adaptations to better suit their environments. Some adaptations have an effect on the organism's metabolism, increasing their chances of survival. Now, this concludes adaptations in endothermic and ectothermic animals.